Now let's say a few words about the significant digits. So let's begin with our angle. Say we have the alpha equal to 21.8 degrees. So all those three digits in this angle are meaningful. So this angle then has the three significant digits. So this guy has 3 significant digits. And if a number has no non-zero digits to the left of the decimal point, for example, you have only 1 0 to the left of this decimal point, then the 0 that follows this decimal point but proceed on non-zero digits are not significant. For example, we may have such a number. We have the 0.00034. So right now in this number, we don't have any non-zero number to the left of this decimal point, right? Then in this case, all those zeros which follow this decimal point and this 3 zeros to the right of this decimal point are not the significant digits. So this number actually has only 2 significant digits. So this one has the 2 significant digits. Now, let's look at one more example. And this time, suppose you have the non-zero number to the left of the decimal point. Then you have the 0 to the right of this decimal point, and in this case, this 0 is significant. So this one, it has the 3 significant digits. Okay? And if you have another number like this, 44.006. So even you have the 2 zeros to the right of this decimal point, this 2 0 followed by another non-zero digit. So in this case, these 2 0 are still significant. And totally this number has the 1, 2, 3, 4, 5 as the 5 significant digits. And we know when we sometimes when we use the scientific calculator to do the computations, we may have the results like this. Say you have the 10 times, you have the 8 times 10 to the 6. And this is called the scientific notation, right? In this case, this one has only 1 significant digit. So this guy has only 1 significant digit. But if your result is like this, 8.1 000 times 10 to the 6. Now, in this case, you have the 3 zeros to the right of this decimal point in this number. Then, in this case, this number has totally 4 significant digits. So sometimes you may add two results, two measurements. Then the answer are only as accurate as the least accurate of the two measurements. For example, you may have the 8 times the 10 to the 6 and plus 28. Then in this case, this result actually has only one significant digit. So the result, the accuracy of the result goes with the least accurate measurement, goes with the accuracy of this 8 times the 10 to 6. So this guy has only one significant digit. Then the sum of these two guys also has only one significant digit, although this summand has two significant digits. Okay, now let's come back to the page 481. Let's review this strategy for solving a right triangle. We just have seen some examples about solving a right triangle. So we try to solve a right triangle. The step 1, use the Pythagorean theorem to find the length of the third side when the length of the two sides are known. For example, we know the A and C, then B is equal to the square root of the A squared minus C squared. See, the step 1, if you know the A and C, right? So you can use the Pythagorean theorem to solve for B. So B is equal to C squared. Okay, the square root of the C squared minus A squared. And if you know the A and B, then C is equal to the square root of X squared plus B squared. Okay, so this is step 1. And step 2, use the trigonometric ratios to find the missing sides or the angles. So sometimes you may just know the one side CC, and you know the one angle alpha. Then in this case, you may use the trigonometric ratio sine alpha, which is equal to the A over C. Then use this equation to find the A. So A is equal to C times the sine alpha. Step 3, use the fact that the sum of the measures of the angles of a triangle is equal to the 180 degrees to determine the third angle when the two are known. So for example, we know the alpha and we know the gamma, which is 90 degrees. Then you can always use the fact that the alpha plus beta and plus gamma equal to 180 degrees to find the third angle, beta. So this is the strategy for solving a right triangle. Now, let's look at some application of the solving a right triangle. Let's look at some word problems.